Hello, and welcome to this conversation about functions as named reusable expression blocks. Let's start from basics. Recall how Scala prefers expressions over statements. An expression is a bit of code that has a return value. An expression block is a set of statements and expressions enclosed between curly braces which have a return value and in that way are an expression in themselves. A function is a further step along that evolution. A function is really just a named, reusable expression block. And once we start thinking about functions this way, we will start to think of expressions, expression blocks, and functions as mutually interchangeable. Let's start by looking at some of the similarities between functions and expression blocks. Basically, expression blocks and functions are both units of code that return a value. Both of these units of code are enclosed between curly braces. Importantly, in Scala, both expressions and function blocks can be passed into functions or returned from functions. This is an important property and a part of Scala's support for first-class functions. Expression blocks and functions both can be stored in values and variables. Expression blocks and functions both can contain nested scopes. In contrast to all of these fundamental similarities, the differences between expression blocks and functions are relatively minor. Expression blocks are usually anonymous, they don't have a name and therefore are rarely reusable. Functions, on the other hand, are usually named. However, Scala does use anonymous or non-named functions often, and anonymous functions blur the line between functions and expression blocks. Second significant difference between expression blocks and functions has to do with parameters. Expression blocks are not parameterized, they lack a list of arguments. Functions, on the other hand, usually are parameterized. The ability for calling code to specify parameters or function arguments is an important mechanism for reusability of functions. From this list of similarities and differences, it's fair to say that when we get right down to it, functions are just named reusable expression blocks, and therefore everything that we've said about expression blocks or just expressions so far can also be said about functions. This is important because it leads directly to the idea that functions are first-class citizens in Scala. Functions are on par with other programming abstractions like objects and classes. This is also a difference, a clear difference between Java and Scala. In Java, it's really objects and classes that are first class entities. In Scala, by contrast, functions are first class citizens as well. I have alluded to first class functions a bunch of times, so let's make it official. There are actually certain explicit conditions that must be satisfied by a language in order for us to say that it supports first class functions. Scala satisfies those conditions, and here they are on screen now. First condition is that a language must allow functions to be stored in variables. Scala allows this. A function can be stored in either a variable or in a value. The second condition is that functions ought to be able to return other functions as their return values. And lastly, just as a function can return another function, it should also be permissible for a function to take in another function as a parameter. This condition too is satisfied. Scala is perfectly okay with functions that take in other functions or that return functions. And that's why we can say that Scala has support for first-class functions. Let's really very quickly run through a few code fragments that illustrate this. Don't sweat the details, but do keep the big picture in mind. Here on screen now is a line of code which assigns a function to a value. And that function compares two strings and returns -1, 0, or +1 depending on the lexicographical relationship between the two strings taken in. Again, don't worry too much if the syntax strikes you as odd. This is an anonymous function, by the way, it does not have a name. Next up on screen now is an example of a function that is returned from another function. Function getComparator returns either the function compare strings descending or compare strings. As you can see in this next slide with a longer fragment, compare strings and compare strings descending are two functions, each of which compares two strings that have been passed in. This is somewhat similar to the use of function pointers in languages like C. Moving on, functions can also accept other functions as their parameters. For instance, the smart compare function you see on screen now takes in a comparison function. A comparison function takes in two strings and returns an integer. Any function that has this signature can be passed into the function smart compare. This is similar to the use of comparator objects in Java. You can see that we have considerably less boilerplate when we do this in Scala. It turns out that support for first class functions is only one aspect of Scala's rich support for functions. Function primitives in Scala go far beyond first class functions. They include closures, which are functions which retain values from their referencing environment. Scala also supports parameter groups. These correspond to logical groupings of the inputs into a function. Parameter groups lead naturally into partially applied functions. These are functions which fix the values of some but not all of the inputs into a function in order to get another function which has fewer inputs. And taking that idea just a little further, if we fix the values of some but not all parameter groups, we get something known as currying. We will cover all of these concepts in a great deal of detail, but for now, let's wrap up with this module and recap all that we've covered so far. Scala is a language that runs on the JVM, but it is explicitly both functional and object-oriented. This is becoming increasingly important as distributed systems gain popularity. We spotted a bunch of functional constructs in Scala that are hiding in plain sight. The ubiquity of immutable data and the preference for expressions over statements. That led into a survey of some of the rich primitives that Scala provides for working with functions, starting with the elevation of functions to first class status.